Okay, in this short video associated with Unit 3, Activity 2, I'm going to talk about some of the key elements and concepts in scatter plots. A scatter plot is a way to present data where I'm collecting data on two variables. So, for example, in this first graph, I'm going to collect data on age and height for a bunch of different people. So, first of all, let's look at some elements of any graph. We have a title describing what the graph is showing. This one's going to show human growth. And then I've got two labeled axes. I've got a y-axis, which is vertical. I have an x-axis, which is horizontal. And each axis is labeled with what is going to be displayed on that axis. So here's height in centimeters, and here's age in years. And each point on a scatter plot represents one piece of data that I've collected. So for example, age, I'm not going to do this exactly. Age might span from 0 to 90. Height might go from 0 centimeters to someone who's 200 centimeters. That's around 6. So, maybe a baby is 10 centimeters. So they'd be 0 on the age and almost 0 on the height. And then each person that I measure, I'm collecting their age, which is the distance on the x-axis, and their height, the distance on the y-axis. So, maybe I've collected a bunch of data. And then once people get to around 20, they don't really grow much. So my data might stay pretty constant. And maybe as older people have worse posture, they might actually start to measure a little bit shorter. So maybe that's my data on the scatter plot. Each point on the plot represents one person that I've asked their age and measured their height. So I've collected, maybe 20 pieces of data to make this scatter plot, and then we can look at the relationship between the two variables, age and height. The only other thing I wanted to talk about is independent and dependent variables. So we're always going to have one independent and one dependent variable. I think the best way to explain it is that the dependent variable depends on the independent one. So the independent variable causes the dependent variable. So in this case, your age affects your height, but your height doesn't affect your age. So you grow as you get older, so your age affects your height. So that means age is independent and height is dependent. And the independent variable we're always going to put on the x-axis, the horizontal, and the dependent variable is always going to be our y variable on our y-axis. The last thing we'll notice is that we've got a positive correlation, especially among young people, because height increases with age. So if the two variables increase together, if the graph is going up, we've got what's called a positive correlation. I'm just going to look at a couple more examples. This one is years of education versus annual income. So again, if you have more education, that might lead to higher income. So education is the independent variable, and it causes your income, which is dependent. And again, I can put on a bunch of data points. Maybe if you drop out in primary school, you don't make a lot of money. Maybe if you drop out in high school, you make a little bit more. If you do, 15 years of education and get an undergrad, maybe you're starting to make more money. If you have a law school or go to medical school, you'll make even more. So we see, again, a positive correlation. More education leads to more income. And again, each point on the scatter plot is one piece of data. So maybe here I've interviewed one person who has a college degree. So maybe they've got, 12 years of education. That's on our x-axis. And maybe they're making, $50,000 a year. That would be on my y-axis. Again, the other thing we might have is outliers. So for example, there are some high school dropouts who start huge successful companies and make millions. So an outlier is when you see a piece of data that is far away from the trend. Maybe we have someone who got a PhD but has trouble finding work, so they have very low income. So we do kind of outliers, which are pieces of data that are different from kind of the general trend that we see. But again, we've got two variables, independent on x, dependent on y, and we have data points showing what we've collected, the data that we've collected. One last example, I've got global warming in Australia. So maybe I'm taking the average temperature of each year. I'm measuring that in degrees Celsius. So we want to be careful that we have units. Then on the dependent axis is the number of wildfires. So temperature causes wildfires because as it's hotter, the grass gets drier, we have more fires. It's not the opposite way around. So maybe in 1996, the temperature was fairly cool and there weren't that many fires. Then as I collect different data points, years when it's very hot, I might have lots of fires. So all three of our examples are examples of positive correlations because as one variable increases, the other one also increases. But you could also think of examples of negative correlation or zero correlations from examples given to you in your course content. So my piece of advice, anytime you're working with a scatter plot, I should have an independent variable that causes a dependent variable. I should know the units of both axes. I should also have a title for my graph. Okay, that's all for now, and that should get you started working with some scatter plots.